This is a recall question. So as we all know, a physical unit, for example, like length, is equal to 3 meter. So in order for this physical quantity length to make sense, we need a number which is a numeric magnitude as well as the unit. Okay, so the answer is B. Okay, we are asked which sequence should be timed to measure the period of the pendulum. Okay, so in this case, we are looking at the motion of one oscillation. Okay, for the pendulum to travel one oscillation, if you were to start from X, it has to swing to the extreme and it has to come back to X. So basically, this kind of motion to and fro back to the same position is called an oscillation. Okay, so the answer should be X to Y and back to X. D. We are given the speed time graph of a car here, and we would like to look at the acceleration. And first of all, we must understand that the gradient of this speed time graph is equivalent to the acceleration. And the gradient, we can also say that it is related to the steepness of the graph. So the steeper the graph is, the higher the gradient and the higher the acceleration. So we can see that the steepness of this graph, right, can be classified under 3 parts. From 0 second to 2 second, it is slanting upwards. Okay, so the steepness is increasing, the acceleration is increasing. And from 2 to 3 seconds is a straight line upwards, so the steepness is constant. So this part we say that it is constant acceleration. And the last part, the steepness is decreasing, so this will be decreasing acceleration. Okay, now we have the question, what is the magnitude of this uniform acceleration? So the part that the acceleration is uniform is this part from 2 to 3 seconds where the acceleration is constant. Okay, so we will write down the 2 coordinate here so that we can use the gradient formula to find the acceleration. Okay, so this point here and this point here, we have the coordinate 2, 10. And this point here, we have the coordinate 3, 20. Okay, now we use the gradient formula y1 minus y2 over x1 minus x2. Okay, 20 minus 10. Okay, y1 minus y2 divided by x1 minus x2. 3 minus 2. That will give us 10 over 1. We have the acceleration as 10 meter per second squared. Answer C. We are given that the weight on Earth is 50 Newton and the gravitational field strength on Earth is 10 Newton per kg. So using the formula, W is equal to mg, our mass is equal to the weight divided by the gravitational field strength. So that will be 50 divided by 10. The mass of the object is 5 kg. So the mass will stay the same whether it's on Earth or on the Moon. because mass is the amount of substance in the body and it doesn't change when there is a change in planet. Okay, so we can calculate the weight on the moon is equal to the mass times gravitational field strength of the moon. So the mass will be 5 kg and the gravitational field strength will change because the gravitational field strength is dependent on the size of the planet, and as the size of the moon is about 6 times smaller than that of Earth, the gravitational field strength is also 1/6 of that on Earth. Okay, so the weight is equal to 5 times the gravitational field strength, which is 1.6. That will give us 8 Newton. Answer B. Okay, to find the pressure of the table on the floor, we just need to use the pressure formula. Pressure is equal to force over area. And the force of the table, it will be 40 Newton. And the area of the table, it is not a 0.001 meter square, which is the mistake of many students. Because we have to understand that one table has got 4 legs. So there is a total of 4 times 0.01 meter square of area that is in contact with the floor. So the area we have to include the area of contact for all 4 legs. So it will be 4 times 0.001. Okay, that will give us the answer as 10,000 Newton per meter square. Answer A.